When we look at an equation, it'll tell us what's happening from the parent function to our graph. If we take a look at y equals negative 3x squared, we've learned that what's in front of x squared controls the shape of the graph. Is it going to be wider? Is it going to be more narrow? If you take a look up here, we have 5 different things we need to do. The first thing we need to do is list the coordinates of the vertex. Since there's nothing here with the vertex form, remember the vertex form is y equals a times the quantity x minus h squared plus k. H and k are our vertex. Well, we don't have any of that, so we can assume that the vertex is 0, 0. The equation of the axis of symmetry, you go off of this saying x equals, because remember it's a vertical line, you take the x value of your vertex and you get 0. Going back to the negative 3, that describes our shape, normal, narrow, or wide. Normal is when a is 1, narrow is when a is greater than 1, wide is when a is less than 1. So in this case, since it's a 3, remember we ignored the negative, it's just a 3, we can say that this graph is going to be narrow. The orientation tells you if the graph is going up or down. This is where we take a look at the negative. If your a value is negative, it goes down. If it's positive, it goes up. In this case, it is negative, so we're going down. We have to graph the function. In order to do that, let's pick some values. Always put your vertex here in the middle, so we're able to see one side and the other. I'm going to pick negative 1, negative 2, and 1, 2. We substitute our values in, so we would say negative 3 times negative 2 squared. Following order of operations, you have to do your exponent first, so you'd say negative 3 times 4, which is a negative 12. If we continue on, we can substitute negative 1 in. This would be negative 3 times 1, which is negative 3. If we substitute in a positive 1, we again would have negative 3 times 1, which is negative 3. And if we substituted a 2 in, it would make this 4, or negative 12. We would graph at this point our points, and we would say negative 2, negative 12, negative 1, negative 3, 0, 0, 1, negative 3, and 2, negative 12, and graph from there. If you take a look, our vertex is at 0, 0, and that shows at the graph. Our axis of symmetry, if we were to draw a line, excuse my pen, if we were to draw a line directly down at x equals 0, it would cut that graph in half evenly. It is narrow, so it's very skinny, and it's facing down. Let's try another problem when we have it in vertex form. So remember vertex form, it said y equals a times the quantity x minus h squared plus k. Where the minus h, if we have a plus in the middle, just like we do here, it has to be a negative. So our vertex is a negative 3, negative 4. The axis of symmetry would then be x equals negative 3, because that's going to cut it right in half. This graph, taking a look at our a value in this case is 1, so it will be a normal graph. And then since that a value is positive, it's going to be up. So to graph it again, you put the vertex right here in the middle, and you would pick numbers 2 above, 2 below, and substitute in. Now, using this equation that they gave us, we can substitute in negative 1 for x. So we'd say negative 1 plus 3 squared minus 4. Well, negative 1 plus 3 is 2. 2 squared is 4, and 4 minus 4 is 0. If we put in a -2, -2 plus 3 is 1, and 1 squared is 1. 1 minus 4 is -3. And if you see that there's a pattern and you put the vertex right in the middle, you are allowed to repeat here. So we would graph our points, 1, 0, -1, 0, -2, -3, -3, -4, -4, -3, and -5, 0, and connect the dots. If we double check our work, our vertex is at -3, -4. Our line axis of symmetry at -3 is a vertical line. It cuts it right down the middle. It is normal, and it goes up. So I hope this helped you.